Hello, my name is Michael Denoyer. It's 24 December 2020. Today I'll be discussing the different hormonal feedback loops in the female reproductive system. As I was reading through the chapter and reviewing some of the dynamic modules, this particular topic was one that I kept circling back around to with a lot of uncertainty, so I felt it was a prime opportunity for me to learn a little bit more about the subject. So let's go ahead and get started. Okay, the female reproductive system is one of the most complex systems in the human body. Together, a few organs and a handful of enzymes and hormones have a pretty tremendous roles to play. A woman's ovaries produce an ova, or an egg, which travels through the fallopian tube, where it may or may not be fertilized by the sperm, and then onto the uterus. If the egg is fertilized, it attaches itself to the thickened wall of the uterus and continues to develop into an embryo. If the egg is not fertilized, the thickened uterine endometriosis sheds through the cervical opening of the vagina, and then the entire process starts over again. The ovaries and the uterus have repeating cycles driven by hormones. Today we're going to take a deeper look into these hormonal feedback cycles in a non-pregnant woman. The ovarian cycle is divided into three phases: the follicular phase, the luteal phase, which are the longest phases, each lasting several days, with a short ovulation phase in between. During these cycles, there are 6 primary hormones that are present, each playing a different role in males versus females. They are the gonadotropin-releasing hormone, luteinizing hormone, follicular stimulating hormone, estrogen in the form of estradiol, progesterone, and inhibin. Gonadotropin-releasing hormone is produced and secreted by the hypothalamus of the brain. It's a tropic hormone whose stimulating triggers and the secretion of the luteinizing hormone and the follicle stimulating hormone of the anterior pituitary gland. The luteinizing hormone is secreted from the anterior pituitary and is responsible for stimulating ovulation. Follicle stimulating hormone is also secreted from the anterior pituitary and is responsible for the growth of the ovarian follicles. Beyond that, it plays an increasing estradiol production. Estradiol is a hormone that's present in much higher levels in women than in men. It's one of 3 forms of estrogen produced by the granulosal cells of the ovaries after stimulation by the hormone of the anterior pituitary. The other 2 types of estrogen are produced at different parts of the reproductive cycles and won't be part of today's discussion. I'll be using the term estrogen, but just know that I'm referring to the form of estradiol. Estrogen has many functions of the reproductive cycle, including maturation and release of the egg by the ovaries, as well as the thickening of the uterine lining. Inhibin is secreted by the granulosal cells of the ovaries and is responsible for the suppressing of FSH. The first phase of the ovarian cycle is the follicular phase and begins in the first day of menses. This is an easy identifiable marker as a start of each new monthly cycle. The follicular phase is a period of follicular growth within the ovary. It lasts anywhere from 10 to 21 days, but we'll say 14 days as an average. During this phase, the anterior pituitary is producing FSH and luteinizing hormone in response to stimulus by the gonadotropin-releasing hormone. As a response to the LH and FSH, several follicles begin to mature. As these follicles mature, the granulosal cells of the follicle begin to secrete estrogen. This estrogen secretion has a negative feedback effect on the hypothalamus and inhibits the secretion of gonadotropin-releasing hormone, keeping LH and FSH levels low to prevent additional follicles maturing in the same cycle. At the same time, estrogen has a positive feedback effect on the granulosal cells and encourages additional estrogen production. As the uterus completes menses and moves into its proliferation phase, the phase in which endometrial lining of the uterus adds a new layer of cells in anticipation of pregnancy, the ovaries move into the latter part of the follicular phase while the endometrium continues to thicken. Estrogen levels continue to rise through the follicular phase. As the follicular phase ends, the granulosal cells begin to produce progesterone as well as inhibin. Estrogen, which previously had a negative feedback effect on the pituitary hormones, switches to a positive feedback briefly and causes a surge in both LH and FSH. The LH surge is much higher than FSH surge because of the production of inhibin, which suppresses the FSH to a degree. This hormone surge is an important part of the cycle as it triggers numerous chemical signals necessary for the final stages of follicle maturation. It also sends a signal to the cervical glands to produce copious amounts of mucus in preparation for possible sperm entry. About 16 to 24 hours after the LH surge and after estrogen and inhibin are at their peak, ovulation occurs. The mature follicle ruptures, releasing the egg into the fallopian tube, where it will be swept off to be fertilized or to be discarded with the next menstrual period. After ovulation, the ovaries move into the luteal phase. During this phase, the remaining ruptured follicles combine with the former granulosal cells to transform into the luteal cells of the corpus luteum. As the corpus luteal phase progresses, the corpus luteum produces increasing levels of progesterone, estrogen, and inhibin. Progesterone is the dominant hormone here. Estrogen production falls off initially after ovulation, then starts up again, but not as strongly as progesterone. The estrogen-progesterone combination produces a negative feedback effect on the hypothalamus and anterior pituitary, which all about shut down the production of LH and FSH for the rest of the luteal cycle. The corpus luteum has a lifespan of about 12 days. If the egg is not fertilized during this time frame, the corpus luteum undergoes apoptosis and begins to degenerate. As this happens, estrogen, progesterone, and inhibin production fall off. As estrogen and progesterone levels fall, it removes the negative feedback effect on the hypothalamus and anterior pituitary, causing FSH and LH levels to resume. Okay, so after about 2 days, the corpus luteum ceases to function and becomes an inactive structure called the corpus albinicans, which is replaced by a connective tissue and eventually absorbed after a few months. At this point, the uterine wall begins to slough and marks the beginning of menses, which also marks the beginning of the follicular phase of the next cycle. And so on, the cycle continues on an approximate monthly basis or so until a woman proceeds into menopause. And that concludes my presentation. Here's my study aid, which is pretty simple. It's an unlabeled diagram with a twofold assessment. First, to differentiate between the ovarian hormones and the anterior pituitary hormones based solely on how they ebb and flow throughout the cycle. And then second, fill in the blank using the available word bank. Note that there are more terms in the bank than there are available spaces on the chart. So there'll be a few words left over. Go ahead and pause the video here, and then when ready, move on to the next slide, which has the answers filled in. If you have any questions, please let me know, and have a good day.